Hello students, this is my second video on chapter light, reflection and refraction for CBSE students and chapter optics for matriculation students. Light is a form of energy that enables us to see things. Light starts from a source and bounces off objects which are perceived by our eyes, and our brain processes the signal which eventually enable us to see. Maxwell predicted that magnetic and electric field travel in the form of waves, and these waves move at the speed of light. This led Maxwell to predict that light itself was carried by electromagnetic waves, which means that light is a form of electromagnetic radiation, reflection and refraction. Reflection is when light bounces off a surface and back into the same medium, following the rule that the angle of incidence equals to angle of reflection. In contrast, refraction is the bending of light as it passes from one medium to another, caused by a change in the speed of light and the optical density of the materials. Common example includes a mirror of reflection and a lens or water for refraction. In this chapter, there are ray diagrams to draw. So, dear students, here it is very important to understand how to draw a ray diagram. So, here how to draw a ray diagram of a concave mirror. So, for concave mirror, you have to use compasses. You have to take the distance of at least 6 centimeter from C and cut an arc at P, that is a mirror. Then you have to, here you can follow my marker. So, you can see the C here and P here. So, you take the distance of 6 centimeter. You can take another distance also. So, it is not necessary you have to take 6 centimeter, but obviously it will comfortable to take 6 centimeter, and mark F with the help of ruler, that is just in between, exactly in between C and P. So, now CF equal to FP equal to 3 centimeter. So, for the ray diagram you need at least two rays. One ray is parallel to the principal axis. This is a ray which is parallel to principal axis. After reflection, it will pass through the focus. Okay, you can follow my cursor. So, that is a parallel ray, principal axis to the principal axis. After reflection, will pass through F. Here in this diagram, you can one more parallel ray parallel to the principal axis, after reflection pass through the F. So, there are two rays necessary for to draw the ray diagram. Okay. So, you have to use the ruler and you have to use the compasses to draw the ray diagram and follow the direction. See, here the arrow mark is very important. So, that is why the arrow mark made here. So, that is very important because it shows the direction of the light rays. Okay. And in the ray diagram, how to locate the images. The point where the two reflected rays intersect is the location of the image. Suppose after the reflection, the two reflected rays, they intersect at a point. So, here in this diagram, so the image will form at F. Okay. So, because the object is at infinity. If the object placed at infinity in concave mirror, so the image will form at F. Okay. So, that is no need to draw the image, it will form. You have to draw the image in that point. If the rays don't appear to interact on the actual side, draw dashed lines backward from the reflected rays to find the virtual intersection point. In that case, virtual image will form. Okay. So, there are two type of images will form. One is real image, the other one is virtual image. So, how to analyze the image? That is also very important in the ray diagram. So, the image will be what kind? Draw a perpendicular line from the intersection point to the principal axis to complete the image. The image formed is inverted and real if the rays meet on the object side. That is very important. If the rays after reflection will meet on the object side, the image will be real and inverted. In the other case, the image is virtual, erect and magnified if the reflected ray extensions intersect behind the mirror. So, in that case, the image will form behind the mirror. Okay. So, the image formed by the concave mirror. So, now I will explain one by one the position of the object. So, in the concave mirror there are various methods, the various conditions are there. The first condition is the position of the object at infinity. In this slide you can see that the object is at infinity. If the object is placed at infinity, we consider two rays parallel to the principal axis originating from the object. These rays after reflection converge and form an image at F, that is focus, the principal focus of the mirror. In front of the mirror, the image thus formed is highly diminished, point size, real and inverted. So, here you can follow that there are two rays, parallel rays. After reflection, they will pass through F. Okay. This is another case. The object is placed beyond C. The object is placed beyond C. So, here also you can follow my marker here, the pointer C here. So, this is an object sorry, the ray which is parallel to the principal axis. After reflection, it will pass through focus. That is the first line. Okay. And the second one is the ray which passes through C, after reflection, which will reflect back at the same path. So, therefore, in the same line it will reflect back. So, both the rays will meet at this point. So, you can draw image here. So, automatically that image is just below the principal axis. So, the image is below the principal axis is a real image, and I explained that the image formed in front of the mirror, same side of the object, is a real and inverted image. So, here obviously you can see that the image is smaller than object. So, no need to learn the characteristics of the image. Some students used to learn the table, they formed the table and learned all the characteristics of the image. No need to learn, the image automatically will form. You just see the image and you have to say what kind of image is. So, in this case, the object is placed beyond C, the image is formed between C and F. The image is inverted and real. Why it is real? It is formed at the same side of the object. So, the next position of the object is placed at C. So, here the two rays emerging from the object. So, here you can see that two rays emerging from the object. One is parallel to the principal axis. After reflection, it is passing through the focus. The other one is just opposite, it is incidence through focus, and after reflection it is bounced back parallel to the principal axis. These two rays after reflection will meet at one point in front of the mirror. So, that point you can draw the image. So, that image is formed, it is the same side of the object. So, that is why it is here a real and inverted image. So, you can see that the size of the image is same size as the object. So, at C only, exactly at C. So, no need to adjust, it is exactly formed if you draw the ray diagram with compasses, with ruler and pencil and all. So, exactly the image will form at the same point. The next position of the object is between C and F. So here also you can see that one ray from the object is parallel to the principal axis. It bounces back after reflection. It will pass through the focus. You can follow the pointer. So other ray is just opposite to the first ray. It is incident through the focus. After reflection, it will bounce back and parallel to the principal axis. These two rays will meet at a point. So that point is same side of the object is placed and it's below the principal axis. Therefore, the image is real and inverted. So obviously the size of the image is above the more than the size of the object. So therefore it is enlarged. The image is enlarged, it is formed beyond C. So no need to learn, students, because automatically it will form. So the image will form if you properly see the distance and of CF and FP. You properly mentioned here. So you properly mark and properly you draw. So it automatically it will form. So no need to learn the size of the object, the position of the object, image and all. Okay. So the next position of the object is, it is placed at F. So you can see that my pointer here, the object is the red color one, is object, this is object is placed at focus. So here also there are two rays, one is parallel to the principal axis. After reflection, it will reflect back through F. So another light ray, it is through C. You know that if a light ray passing through C, after reflection it will bounce back in the same path. Okay, so you can see that. So obviously you can see that the two rays after reflection, it is parallel. So therefore the image is formed at infinity. So it is highly enlarged because it is a parallel line and real and inverted. So this way you can draw the ray diagram of the concave mirror when the object is placed at F. So the next position is between F and P, focus and pole of the mirror. So when its object is placed between F and P, the rays considered here are ongoing parallel to the principal axis, the first ray. So you can see the point. So parallel to the principal axis. After reflection, it will bounce back through F. So another ray will pass through the center of curvature. So will bounce back at the same path. So here, so these two rays are converging. So they never meet. So if in this case, obviously they appear to meet in the back side of the behind the mirror. So you have to draw the dashed lines, dotted lines here. So they appear to meet behind the mirror. So here where they meet, you can draw an image. Obviously this image is formed above the principal axis. So it is a virtual image. So it is enlarged image and virtual image. So now image formed by a convex mirror. So obviously in convex mirror always form the virtual image. Why it is virtual image? Because the center of curvature is behind the mirror. So here in this case the object is, there are two position you can see. One is the object is at infinity. Here you can see the object. So there are two parallel rays which is parallel to the principal axis. After reflection, so they diverge. See, these are the diverging rays. Okay, see here. So they never meet at the same side of the object, but they appear to meet at F, at focus. So here the image is formed behind the mirror, at focus, highly diminished, virtual and erect image will form. So the next position is between pole and infinity, between pole and infinity, anywhere you can place between pole and infinity. So here this is the object, and first ray, the parallel to the principal axis, it will diverge. Okay, after reflection it will diverge, and you can draw a dotted line here. Okay, it will pass through focus, and the next ray will pass through the center of curvature. You know that the center of curvature of a convex mirror is behind the mirror. So the center of curvature is here. So you know that when a light ray passing through the center of curvature will bounce back in the same path. So when these two rays will meet, you can draw a image. So very small image, it will form between P and F. It is erect, and it is virtual, erect and virtual, because virtual image always found behind the mirror. Okay. So now, dear students, so we will discuss about the uses of spherical mirror. First of all, we will see concave mirrors. So concave mirrors is used as a shaving mirror. Okay. So most commonly used in shaving because of their reflecting and curved surface. The concave mirror forms an enlarged and erect image of the face when the mirror is held closer to the face during shaving, and it is used in astronomical telescope, and it is used by the eye doctors, ophthalmologists, to see the retina of the eye, and it is used in the car headlight also. So concave mirrors are used in car headlight, and concave mirrors also used in solar furnaces. So these are the uses of concave mirror, and some uses of convex mirror. And because of they have the wider field of view, they are curved outwards. They are commonly used in automobile side mirror, rear view mirror. In automobile, you can see the rear view mirror. So that mirror is a convex mirror. Okay, and it is used in the security purpose also. It's a good, because it is a single security personnel could see large portion of the store while monitoring from the single location. They also used in driveways and roads, provide safety to bikers and drivers. In ATMs also you can see the mirror. So that is for the ATM users. So you can look the wider view behind you, what is going on behind you, that you can see that. So the mirrors are used. So dear students, so thank you for watching this video. I will publish more videos in this chapter. So you do one thing, you watch the videos again and again. I already told you many times. Then you read your book again and again, and try to answer the question answers in your book. Okay, so you have to understand the concept. This videos are useful to understand the core concept of the chapter, because understanding is very important. So till then, bye bye. Thank you.